Hi guys. So in this video, we're looking at when cos is when cos is odd. So basically, we're still back to integrating cos of cos to the power of n of f of x. But now in this case, n is odd, meaning that n is a 3, 7, 1, 11, a number that a number that when you divide by 2 gives you a remainder. So now let's start. We say that if when n is odd, so if you have cos of cos of f of x to the power of n, when n is odd, then you'll use the following identities. So then you'll have cos of cube x is equals to, remember when with sine what we did is we had an odd part and an even part. But the even had the power of what? Had the power of, the odd had the power of 1. So same here, we have to separate that. Reason being, we want to use the identity sine squared x plus cos squared x is equals to 1. Now, remember for sine, what we did is we said sine squared x is equals to, we take the cos on the other side, this became 1 minus cos squared x, all right? This is the identity we use. Now for cos, we then take sine to the other side instead. So it will be cos squared x is equals to 1 minus sine squared x. So let's do that. So we separate this this odd, because n is odd. N is equals to 3 and it's odd. So we separate it into the even parts and the odd part. Now the even part, the odd part will have a power of 1. So we know the odd part will have a power of 1. So this is cos of x. Now we know that for us to get 3, we then have to have cos squared of x. So the cos squared of x times cos x gives us cos 3 to the power of x. The reason why we're doing this is because we want to use this identity and substitute where we see the even part times cos of x. So this is the identity we're going to use. So let's look at cos to the power of 5. Now cos to the power of 5 of x is equals to, remember we said we have the odd part will be power of 1. Sorry about that. So the odd part will be power of 1. So this will be times cos of x. Now we know the even part will be cos of x, to the power of 4. Now, because our identity says cos squared x, meaning that we have to go and then rewrite the even part, which is this one, in such a way that it has a cos squared. So let's do that. We know this can be written as cos of x squared. Okay, let's say cos squared of x squared times cos of x. Then we can be able to go and use this identity over here. So then this is equals to 1 minus sine squared of x squared times cos of x. So it's important that you then change the odds, have one odd times even power, and then apply this identity over here. So now let's look at an example. Let me erase, then we look at an example. Now let's look at example 5 from page 16. It wants us to solve cos to the power of 3 of x. So let's do that. Now we then say integrate cos of 3x dx. The power of cos, which is this 3, you can see that it's what? It's actually odd. And since it's odd, it means that we're going to use the identity cos squared x is equals to 1 minus sine squared x. Right? Now, since then, we are looking at the odd part. So remember we said we need to split it into two, the odd part and the even part. So let's do that. And the odd part will have a power of 1. So we know the odd part will be cos of x. Now times, we need an even part such that when you multiply with this, the power of 1, it should give you a 3. And we see that this is cos squared of x dx. Then we go and apply that identity. So then this is equal to the integral of, we apply it here, so it's 1 minus sine squared x times cos of x dx. So then we multiply the cos inside the brackets. So this becomes cos times 1 times cos, this becomes cos of x minus 1, cos of x times sine squared x. This is cos of x times sine squared of x. Remember that we can then take the integral of the individual terms. So this is, sorry about that. So this is the integral of cos of x dx minus the integral of cos of x times sine squared of x dx. Okay, so now let's simplify. We need to go back and check that if I have cos of x, what did I differentiate to be able to find what's this cos of x basically? Or you can look at it in this way, where you just go straight and use the formula and you say, okay, fine. We know that if I'm integrating f of x times cos of f of x dx, then the answer is sine of f of x plus c. Now we're looking at this part over here. So in this case, our f of x is equal to x, and then f of prime of x is equal to 1. So meaning that we need to rewrite this. So this is the derivative, right? So we need to rewrite this as, so it'll be 1, the derivative times cos of x. So this is just cos of x. So there's no need to introduce the what do you call, there's no need to introduce a constant because this looks exactly the same as this. So we can just apply the rule. Now, okay, let me erase so that we look at the second part. With this part over here, you will see that we have the integral of cos of x times sine squared of x dx. You can also write this as the integral of cos of x times sine of x squared dx. Now, if you look at this, you see there's a function that has a power and the derivative of that function is there. So now this is also nice to ask because we know that there's a rule that says if you're integrating, right, a function f of x to the power of n times the derivative of f of x dx, then this will be f of x, let me put brackets, n plus 1 over n plus 1 plus c. Now, if you look at this, we have our f of x is equals to sine of x. Now, our derivative of f of x is equals to cos of x. And our n is equals to 2. If you substitute in here, you will notice that we have what? We have the derivative, which is what? Cos of x times, so we have the derivative cos of x times f to the power of n. Now, our f is sine of x to the power of 2. So this looks exactly the same as that one. So there's no need to introduce what? There's no need to introduce the constants in there. So meaning that if we erase this part, therefore this part over here will just be f of x, which is sine of x to the power of 2 plus 1 over 2 plus 1 plus c. So then we can go and substitute. Let's now substitute. So then we know that this, we said that this is just sine of x minus, we said f of x is sine of x, and is 2 plus 1 over 2 plus 1 plus c is equals to sine of x minus sine of x to the power of 3 over 3 plus c. Therefore, we then we're able to solve cos squared x dx equals to sine of x minus sine of, or you can also write it like this, sine to the power of 3 of x over 3 plus c. And that's how we solve this particular problem here, where we integrate cos to the power of 3x with respect to x. Thank you. Bye.